combined, that means we're adding like terms. Here's their grid. What does a like term mean? They're the exact same what? Variable, and then something else that is getting thrown in. If there's an exponent on the variable, like terms have to have matching exponents as well. So we're looking here. Are there any other x squareds within this part? Yes, there is an x squared in these two spots. Nowhere else. Combining means you are adding them together. So if I am adding those three circle terms together, what does that create? A positive and a negative cancel. So we're left with 6x squared. Okay, let's try another one. Y. Okay. Y, there's no y there. 9y, so that's 18. Plus 3 more.
11.
Then another one. And then this one. And then. Ooh. Let's talk about it. Is this x, y a like term? Why not? It has another variable with it. So the only like terms are purely just y. So all of those things I just circled in green, what would they combine together to get? U. Okay, so 33y. Things to make sure we're careful with. At this point, we are combining like terms. If I gave you a problem like this, if I gave you that problem, I told you to solve it. Like, solve the equation just like normal. These are on the same side. They would combine together. What would you get? 5x plus 4 equals 14, and then you keep going to solve it, correct? Did a variable just change there?
No.
So, combining does not change our variable exponents. So when we're combining our y's, it is going to stay as just 33y. Not y to the whatever extra power you want to add in. That is multiplying and dividing. It's combining, multiplying, and dividing. No, it is just adding. Okay, so what I want you to do, go through and find the rest of like terms, combine whatever you can on here. Our first vocabulary word, our first big vocabulary word for today is polynomial. A polynomial, we are going to do operations. We have a few weeks of, like 2 weeks of doing polynomial operations. Today is adding and subtracting. We are going to multiply with them. We are going to divide with them. We are going to do something called factoring, if you have heard that term before. We are going to be doing all kinds of things with polynomials. Before we get to what a polynomial is, we've got some vocabulary words. We have terms, we have like terms. We're going to add in 2 other vocabulary words. This is on the paper that has like the little mapping thing, the little sort of ovals at the top of that page. Okay, so term. A term is what a term is. It's the part of an expression separated by plus signs. It could also be minus signs. Because a plus sign and a minus sign, like a minus sign is adding and negative to, so that's why it's technically a plus sign, but plus or minus sign. So I gave an example. That is an expression. And this expression has 3 terms. Then the next part, we have terms, and then there are like terms. That's what we were just practicing. Like terms meaning they have the same variables and exponents. That's the new part to terms that y'all probably haven't seen. A like term has to have a matching exponent. I have a large expression. It currently has 5 terms. Within those 5 terms, are there any that have matching variables and exponents? Yes, that means that expression can be simplified. Things can be combined. We have a 5x squared and a negative 2x squared, which could combine to be 3x squared.
And then negative 2x squared.
Then there's an xy. If there are multiple variables, as long as there's something else that is xy, that is considered a like term. So that negative 11xy, those are like terms. So we can combine those coefficients together. 2 and negative 11. Or sorry, 9 and negative 11 is a negative 2. And then the last one, since it has xy, but there's a squared on the y, that's why it's an odd out. It doesn't have a like term with it. So we just condensed that expression from 5 terms to 3 terms. Are we okay with that vocabulary so far? I'm using a lot of vocabulary today. We're going to add in 2 more vocabulary words also. We're going to add in the word coefficient. And constant. Coefficient and constant. You should know those words. Definitely the first one. What's coefficient? A coefficient is a number in front of the variable. Yeah. Technically, it's the number that multiplies with the variable, but it's like a function. So if we look at that last example, 3 is a coefficient, negative 2 is a coefficient, 2 is a coefficient. Those are coefficients. What about a constant? Who remembers what a constant is? Exactly. A constant is a number without a variable. That's why it's called a constant. Right? There's no letter next to it, so it's never going to alter. Because variables are unknown to alter numbers. You're going to have to be very comfortable with all these different vocabulary words. A lot of these are refreshers of old vocabulary words, but they're going to come into play a bunch with our topic, this little section. We're going to use these vocab words a lot. Okay. On to more vocabulary. Finally tackling a polynomial. A polynomial, the technical vocabulary thing for it. It's a monomial or a sum of monomials. Now I know that you don't know what that word means. A polynomial is a fancy name for an expression. A polynomial is a fancy word for an expression. Anything other than these 3 special types of polynomials is just called a polynomial. But there are 3 that have specific names to it. Okay, let's use a little bit of y'all know prefixes?
Yeah.
Give me a guess. What do you think those mean? Try by mono. 1, 2, 3. A monomial has 1 term. binomial has 2 terms, and a trinomial has 3 terms. Monomial has 1 term, binomial has 2 terms, and trinomial has 3 terms. Okay. So as a refresher, when we're talking about binomial, trinomial, monomial, it's just after combining terms. So all of these examples, nothing can be combined. Anything after 3 terms, like it has 4 terms, 5 terms, 6 terms, polynomial. Like there's no quadnomial, there's not like a pentanomial, a hexanomial, like that's not, no. Anything past 3 is just considered a polynomial. Now that we have now talked about all of our vocab, we are now done with vocabulary pretty much. We have one last little thing, but we're pretty much it. What we are doing with these polynomials, we are adding them together. We are subtracting them. We are going to multiply them. We are going to divide them. Today is just adding and subtracting. Before we start adding and subtracting, we're going to talk about algebra tiles. Do y'all remember having these maybe last year, 6th grade? We don't get to have them like out because of COVID, but you can still draw them. You still need to know what they represent. So there's 3 different types. There's 3 different sizes. There's a little square, there's a rectangle, there's big square. There's a colorful side of either red, green, or yellow, and then there's a red side. Hopefully everyone knows what the red means. Anyone? Red means negative. Okay. If you are trying to show negative when you draw a picture, just color it in. It's because you don't need to have like red markers. But do y'all know what the different shapes represent? Okay, I heard the ones. What is 1? The tiny one. So,
the X one.
this would be a 1. This would be a negative 1.
Or the X one.
Negative X squared.
These are called algebra tiles. If you are thinking that it is 1/1000, those are 10 base tiles or like 100 base tiles, whatever. That is not algebra tiles. Algebra means we need to throw in the letters. So this is considered an X, and this is a negative X. And then the largest squared is called an X squared, and then this one's a negative X squared. Yes, if you peeked at your notes, you saw that. The reason it's called an X squared, if y'all look at what I actually have in my hand, like the large squares are made by X by X. Like the size themselves is an X by X square. Get it? So X squared. Okay. So we're going to go through and we're going to draw these. We're going to do a little bit of drawing and then some without drawing. That's going to be our like pattern for all of this. We're going to have to draw to start every time we get to a new operation. Add, subtract, multiply, divide. We're always going to start it by drawing. Then we'll learn how to do it without drawing. Today we're going to do a little bit of drawing, but mostly without, because it seems from what I just witnessed from y'all like beforehand, I think y'all can probably do it without drawing, but we're going to do it with. Just practice. We're going to start with adding. We are adding, if we look here, new vocabulary word. It's 2 sets of parentheses. That's a binomial plus a trinomial. Yes. 2 terms plus 1 term, or 3 terms. Drawing that out. 2x squared. That means we need 2 of the x squares.
Yeah, but no, negative X.
Okay. And then we need a negative x, so we've got a negative x. Was there anything in front of that parentheses, in front of that binomial to change that, like anything about it?
No.
Okay, let's look at the trinomial. That is also in parentheses. Is there anything in front of those parentheses to change it, to alter it?
No.
You see a number to distribute? Do you see a negative anywhere? Like, no, nothing's changing. So we're going to keep it the same. It is an x squared, 3 x's, and then a negative 1. Okay, we have successfully modeled this situation. Now we are putting it all together. How many x squares are there?
3.
3. So to write that algebraically, 3x squared. What about x's?
2.
Oh, why is it only 2?
Because the negative.
Okay. Does anyone have a little term? Is there something that's called
Like cancel.
they cancel? Does the word zero pair sound familiar?
No.
Things like that. Yeah, all that comes back. Okay. So plus 2x and then minus 1 is our final answer to that problem. Now this is where I need y'all to make sure you are thinking about it when we combine like terms. The reason our exponent doesn't change, the reason it's still x squared, did that shape change at all? No, it's still large squares. It's not all of a sudden like a triangle. So you're not changing the x squared part, you're just changing how many there are. So the coefficient is changing, not the variable. Okay, we're going to do the one next to it. The one next to it, I think we can maybe try without drawing it. First parentheses, so that's a trinomial plus a binomial. Is there anything in front of that first set of parentheses? No. Is there anything that's going to alter or change the second set of parentheses? Okay, as trivial as it sounds, I am going to rewrite this without the parentheses. The reason being, sometimes there are things that are going to change our different polynomials. And if you just get in the habit of like just combining them without thinking about it, you're going to make those little mistakes. So I just rewrite it, no parentheses, nothing changed, but just taking away the parentheses. Now on to combining like terms. X squareds are considered like terms. So what would that be?
4x squared.
Okay. And then plus 2x. And then our ones cancel because you have a positive and negative 1. Which means you don't write any constant down. The constants have canceled. And there's your answer. Okay. Do we feel okay about adding polynomials together?
Yes.
Wonderful. Let's go on to subtracting polynomials. Subtracting polynomials. On that first example, we're going to go back to drawing it. We have a trinomial plus a trinomial, vocabulary words. First set of parentheses. Is there anything in front of the parentheses to alter it?
No. There's a negative on
In front of the first one. Oh, no. Okay, so that means it's going to stay as is. You don't need to worry about anything changing. When it comes to that second set of parentheses, is there anything in front of it that will alter the parentheses? Yes, there's a negative sign. What does a negative sign do?
Reverses all the other signs.
It means it's the opposite of everything in that set of parentheses. So it's a positive 2x squared minus x and then a minus 1. So that is what we are now drawing for our model. 2x squared, a negative x, and a negative 1. Bringing all of those now together, what have we now modeled? How many x squared are there? 3x squared, We have a 0 pair for x's. So x's have canceled. And then minus 2. Okay. So if you didn't catch on to it, subtraction makes a difference with your parentheses. So you've got to make sure you're careful. Adding the parentheses, you're just like combining together. But subtracting, there is a change that has to happen. That's where we're going to see mistakes, like little mistakes of like messing up with signs and things like that. So just be careful with it. Example 4. Trinomial plus or minus a binomial. Vocabulary. Isn't that fun? First one, first set of parentheses. Is anything going to change here?
No.
Okay. So 4x squared plus 3x minus 7. Second set of parentheses. Is anything changing there? Yes. There is a negative in front, which means it is a negative x squared and now a plus 2x. So when we combine like terms, x squared combined. If we had modeled that out, it would still have a bunch of squares. How many x squareds are there? 3, because one of them would be canceled out. So 3x squared. What about the x's? 5x. And negative 7, there is no other constant, so it is minus 7. Okay. Now before we move on, you are going to see this in directions for this whole section. It is always going to say, or sometimes it says it, sometimes it doesn't, but it's always implied that you write your answer in descending order. This is an example of descending order. So is this one. I have written all of the answers in descending order. Every answer we have done so far has been descending order. Anyone have a guess what descending order means? How? Correct. The exponents are decreasing. So the highest numbered exponent comes first, and then we go down in order. The constant, the thing without a variable, is always last. That's called descending order. Now, if you don't do that, am I getting kind of wrong? No. But where it's going to come back and kind of get you is later on in future sections, you have to have things in descending order to start the problem, which means you can't like actually solve anything unless you got the right order first. So you might as well just practice it now. But that's called descending order if you see it anywhere else. Okay. Last one. The last one we are not going to draw. Look at them. How come we're not drawing those? There's a y cubed. Now, could you make up a shape to be a y cubed? Of course, you could. But if we look at number 6, those are also like different things. So I want you all to try and combine, like simplify those without me. Any questions? We're okay? All right. The second page is what your homework, like your homework.